Hello, hey guys. So a few years ago, a friend of mine who was very depressed, having a hair fall problem. So he went to a doctor and asked, you know what? I hear that shaving my head off stops the hair fall problem. And the doctor was kind enough to say that, yeah, of course, when you don't have any hair, of course your hair fall problem would come to a stop. But that's not going to the root cause, and that's always true with RecyclerView as well. So any optimization that you may apply might get you lucky, but not always, because until you find out the root cause, it's not going to work out. So that's what I'm going to share with you, because I found out a few ways of how to debug the performance of RecyclerViews using Systrace and Perfetto. Cool. So let's get started. And yeah, so whenever there is recycler views, it's all happening on the UI thread. Right? So every frame on the phone has to be rendered in 16 milliseconds, and which means it has to go through layouts, measure, and draw faces. So that's already a lot of work. Right? So please don't make any more work on the UI thread. And of course, so now comes the problem of skipped frames. So when a recycler view is laggy, when a recycler view is slow, and when a list is very slow, it's most often related to skipped frames. So let me give you an example of what this looks like. Right, so let's assume a recycler view with 5 items on the screen, and let's say each item takes 5 milliseconds to render. So totally we have 25 milliseconds to render this screen, whereas you only have 16 milliseconds to render one frame on the screen. So you're overshooting by 8 milliseconds. So which means that the phone's capability to render a frame in 16 milliseconds is not enough, which means there has to be some process that has to be skipped. So that's when we see a lag in the UI. But how do we figure it out? So how can we figure out what's going on? So which frame is being skipped, or what is causing this skipped frame? And that's where we'll do a demo of a simple application where we can walk through how to find out the root cause using Perfetto. So I have a pretty simple application over here, which is just a simple recycler view, which has a couple of elements on the screen. So it's just the all the cities in a specific country. So that's about it. So as you can see, as I scroll through this recycler view, it in fact is laggy. So now let's assume that you joined a new company, or you're looking at a new code base, and this is all you see. And so where do you start? Right? So I can see that the recycler view is laggy. The screen is a bit laggy. So as I scroll through, it's not really smooth. It gets stuck in a few places. So now there is a tool in the developer options which can help us to see what's happening. And so what? Let's do something. Let's go to the uh, developer options, and there's something called the GPU rendering. So once let me just enable this GPU rendering, and then let me show you what this guy does. Yeah, so it's called GPU rendering in some phones, and then in some phones it's called HWUI rendering. Right, so let's select this on screen as bars. Now you can see a lot of fancy colors that are going on in this screen. Right. So let's go through the application and then see how these colors span out. So I'm scrolling through this application, and you can notice that as I scroll through the application, as I scroll through the screen, the number of horizontal bars that are on the screen, they are pretty large. So now you can see that there are a lot of horizontal or vertical bars that appear on the screen. And you can see a red line, a horizontal red line in the screen as well. So this horizontal red line indicates a 16 millisecond threshold. Right? So any line which is above this 16 millisecond threshold means that there is something that's happening on the UI thread. Right? And yeah, so you can see that there are lots and lots of vertical bars. Right? So this is the first investigation that you can do. Right? So once you go through this, once you enable this hardware UI rendering option, and then walk through your application, if you see a lot of vertical bars which are above the red line, then that gives you an indication that there is something that's going on in the UI thread which you can optimize for. Right? And now we have figured out that there is something that's going on in the UI thread which is not very optimal. So now let's go into the code base and then see how we can find out what's happening over there. So there are two approaches to finding out what's going on over here. And so one is you do a visual code inspection and then see what's happening, and you may get lucky if you can figure out a few things that are out there, but not always. Right? So if you are working on complex code bases, so reading through the code can't help you a lot. Right? So what? Let's do something. Right? So let's go to this. Uh, let's go to this adapter and then see if we have any clues out there. So this is called the items adapter. Right? So what we can do over here is our main intention over here is to see what's going on in the UI thread. Right? So when it's the recycler view, then I can relate to the on bind view holder. Right? If I can find out how much time the on bind view holder is taking, and then that gives me an indication of uh, how much time it's taking to render. So let's try to measure how much time the on-bind view holder takes to um, render, takes to complete. So that's a handy API that comes with us, which is called the trace.begin section. So what I'm going to do over here is I'm going to measure how much time is this on-bind view holder is taking to execute. So what I'm doing is I'm using the trace API, and I'm calling the begin API, begin section API within the trace class, and then I'm giving it a name called perf on bind view holder. And then so I'm starting the trace over here, and let me close the trace over here. Trace start section. Cool. Now I have put two traces. One, I have put a trace over here. So hopefully, with this trace, if I can run through the application, then there's a trace file that we generated, and I hope we can get some insights into this trace file. So let's do something. Let's compile this application and then go over this. So ./lw. So debug. Cool. While it installs, let me set up a few things over here. First, I'm going to disable the. All right, so let me disable this inspection. All right, so and there's another thing over here called the system traces. So system traces is what can log all the information and give us a file which can have all the information about what's going on in the UI thread. So let's check where this guy is. Yeah, there you go. So now we can see that there is something called system tracing. So yeah, so I have now we have all the defaults set in place, and then I have put a quick setting style so that we can access this right inside the notifications bar itself. So now let's do something. So now let's start tracing, and now let's start tracing, and so the trace is being recorded. Now let's run through the application, and let's do a few scrolls. All right. So after we do a few scrolls, now let's stop tracing. All right. So now the trace is saved. So now what we have effectively done is the code is deployed inside the phone with a few trace markers. So now and there is a file which is generated which did some instrumentation, and now this file is saved. Now let's pull this file to our computer and then check if we have any clues out there. So we can pull this using ADB. So most often than not, so it's present inside slash data slash local slash traces. And I'm pulling this guy out of here, and now cool. So now to recap what we did, and so we had a problem with the recycler view, and we had put tracers inside the on bind view holder and deployed the application, played around with the application while also instrumenting. And after we stopped the instrumentation, a file was generated, and we have pulled the file into our PC. Now let's go ahead and see if we have any insights. And so I'm going to ui.perfetto.dev, right, and then I'm going to open this traces file. Okay, this traces file is present somewhere, uh, should be somewhere in here. Yep, so you have traces folder. Yeah, so this is the guide. Yep, cool. And let's wait for the trace to load. And this is huge amount of information that we will be seeing over here. But let's just concentrate on what we need right now. So now we are yeah, obviously this is just an overload of information, but just let's just look into what we are interested in. So our application name is called com.codec.prefer.debugging. So let's go into this, and here we can see a lot of threads. So what this guy has done is he has captured the all the threads that are there in the application and what is happening in each of those threads. So obviously you can see that there is a Perfetto debugging, which is most probably the main thread, and you can also see that. All right, so we can see a lot of things going on with respect to the on-bind view holder. Right, so this is traversals, layout, and then RV on layout, which means recycler. That's something that's happening on the recycler view. And yeah, this is a lot of information. But what do we look out for in this? So if you remember, so we had put some trace markers. Right? So the identifier of this trace marker is perf colon on bind view holder. Let's search if this trace marker is present in our dump. Right? So we get this. Perfetto gives you a handy option to search something, right? And yeah, so that's a hit, which means we have our trace is captured. And if we can look over here, right, so inside this details section, we can see that this particular segment of code took 511 milliseconds to execute. Right. So 511 milliseconds is just way too much. We just have 16 milliseconds, and this is at least more than 100 times or more than at least 50 times the desired limit. And there are other things as well. So this is around 93 seconds. This again is more than 5 to 6 seconds. Then we have another section which is 334 milliseconds. So as we can see, this is non-optimal. So now we know that there is what we have found effectively is something is wrong with the on-bind view holder, which is what is holding us back. So this trouble with the on-bind view holder method, there's just too much work that's going inside the on-bind view holder, and that's what is holding us back on the performance. Now let's jump back into the code and then see what's happening over there, and then let's see what's if we can improve something out there. Right? So with this information, cool. So we can see that this is the only thing that's happening inside the on-bind view holder, and it looks like a for loop. And once we iterate through this for loop, there is a text view that is being created, and this text view is being inserted into some sort of a holder. Right? So the hypothesis that we can make over here is this guy over here could be the small text views, and these guys are being added over here. So obviously, now we can see that there are so many text views which have been constructed, and then they are added into a view right inside on-bind view holder. So there is something that I can right away think. Right? So this looks like a list, right? So and a list doesn't really need to be populated one by one iteratively inside a parent layout. So if we can utilize a recycler view over here, then instead of iterating to all the items to inflate, we would just iterate through the items that needs to be displayed. And so that's a definite optimization that I can think about. And let's replace this whole section with a recycler view, and then let's see what's the improvement in performance. So for the sake of demo, I have already created that, and let's see if we can go inside it, and then uh, all right, cool. So there we go. So that's the horizontal scroll view inside which we are inserting all the small text views. So let me just replace this horizontal scroll view with a recycler view. All right, cool. So going back to the adapter, so I need to change over here as well. So right, so let's enable this um, recycler view over here. All right, cool. Um, yeah, so there's a chip adapter as well over here, which is pretty straightforward. Um, yeah. So now what we have done over here is this component which we see over here, which is this horizontally scrollable list of items. Earlier it was a horizontal scroll view where all the items were added. So now we effectively replaced it with a recycler view. Now let's do the same thing over again. So now we have done some optimization. Let's try to instrument this again. First, let's try to let's see what's happening in the hardware UI rendering section. And then let's record the traces and then see what's happening. Okay, so cool. So let me build this guy again. Let's wait for the build to complete and then let's go ahead. So before the build happens, let me go ahead and then enable the HW UI rendering option again. Alright, so it's built. It's awesome. Cool. A recap. So we have replaced the horizontal scrollable view, which was causing trouble, and we have replaced it with a recycler view. So if there were 10 items to be inflated on a screen, now we would just see all the items that need to be inflated just for the space that's available on the screen. So this definitely should give us some performance improvement. And let's see if we have them. Not bad. Right, so not bad. So the horizontal bars, the vertical bars have reduced, which was not as bad as the earlier one, and it's much smoother as well. Cool. So this has given us some improvement. Now let's go ahead and let's measure what the improvement is. So let's disable the all right. Now let's disable and let's cool. So let's start recording the traces. Launch the application. All right. So my emulator is behaving crazy. So maybe the demo gods are not so kind to me. Let me try to get rid of all these guys. Stop tracing. Never mind. Stop tracing. Launch the app. Run through the app. Stop tracing. Cool. The trace is saved. Now let's pull the trace to our PC. All right, so it has been pulled. Now let's go ahead and see if we have some improvement. Again, I'm going to your perfetto.dev, open the trace file, open the one that was saved pretty recently. This guy most probably. Let it load. Cool. Now let's go ahead and search what we care about, which is this guy. Let's see if this section of code has reduced in execution time. All right, so now we can see that as I walk through these guys. All right, so there is one perf one point view folder. So now we can see that the duration is reduced to 369 US. So this is microseconds. So from milliseconds we have reduced to microseconds. Now let's see a few other occurrences as well. So silver, same thing. Right? So from milliseconds we have come way down. So from right, so the largest one over here is 1 millisecond. Right? So which is a good sign. And then 640 microseconds, 740 microseconds. All right, cool. Yeah, and then we have 1 millisecond and 446 microseconds. So it's very encouraging, right? So we have uh, come down from 500 milliseconds, 300 milliseconds, 90 milliseconds to now 1 millisecond as the maximum. So now there's a validation that the optimizations that we have done is giving us some good results. Right? So and we have validated this using two tools. One is the Perfetto traces, and the other one is the HWUI rendering option in the developer options. Now let's see if we can improve this even more further. So if we can see uh, the create, so we can see that the create phase, like the on layout phase, which is where the recycler view is being created, and inflate is taking the most amount of time because there is this material design chip component which is taking the maximum time for creation, right? Which is taking 4 milliseconds for creation, and it happens to be this small chip. So so what I'm thinking over here is, what if we can use a text view instead of a chip, right? So if it can give us even much more improvement, right? So we can see this. You can see that while the on create is being executed, most of the time is being spent on the uh, chip inflation, which is the material design chip component. So if we are working on geographies where the phone is limited with its memory capacity, then we can maybe probably simulate a chip view with a text view. And now let's replace the chip with a text view and then see if we get even more visible improvements. So let's go ahead and we have this chip layout, which is where we have a chip as the component. Now let's try to get rid of this chip as the component and replace it with a text view with a similar background so that we can give the user a feeling of seeing a chip as well. Then now let's see where this goes. So obviously we need to replace a few things. All right, cool. Now let's build it, do the same thing again, and then see what happens. meanwhile, let me also go ahead and enable the options on screen as bars. Nice. All right, so it looks much similar to the chip as well, and it feels a lot smoother. And you can see that the vertical bars are uh, almost 90% of the time not crossing the horizontal red line. So it means that our optimizations have worked out. Let's validate our optimizations. So now all we need to do is record the traces again, load it inside Perfetto, see if it's working there or not. Let me get rid of this. Let's start tracing again. Let's open the app, play around, play around. Cool. Stop the traces, pull the trace. My laptop. All right. Open this guy again. The latest trace that we captured. Let it open. All right. This is what we're interested in. Let's see how we have improved on this. Now the on create view holder also should have been reduced a lot. All right, so now it's nowhere to be seen. So uh, the chip component is nowhere to be seen. Now let's see if we have improved on the inflate performance as well. Cool. Yeah. So we can consistently see that the inflate phase also takes very less time, like 2 millisecond, 1 millisecond, 1 millisecond, 4 milliseconds. Right. So it has also reduced from around 5 milliseconds to 1 millisecond. So this is another success that we can validate. Cool. So yeah, so this is how I've been using Perfetto and Systrace to debug some performance issues with the recycler view, and yeah, and these are and the common sources of slow recycler views that I have found out in my career or passing data objects on bind view holder, writing business logic inside on-bind view holder, and yeah, highly nested hierarchies, complex views in which views are hidden and shown a lot. Right? So that could be use cases where a single layout has lots and lots of views, and based on business logic, views are shown and hidden. Right. So that's another source of concern. And then If you go too generic on views, right? So views over a period of time tend to get bloated during product iteration, and that at some point of time causes lots and lots of performance regressions. And the other one is too many types, too many view types. Right? So if there are more than 20, 30 different kinds of view types that are existent on inside the recycler view, then the on create view holder method is going to be called very often because the recycle pool size might be small, right? So too many views also causes a lot of trouble. And what are the alternatives? So there are a few alternatives that are out there, and epoxy and litho have are good, and litho is even good because I just discovered that litho has very fine-grained optimizations on a view level rather than a view type level. Right? So imagine you have two view types, right? So litho goes a bit deeper as well. So it recycles not view types, rather it recycles views. And so if there are two view types with only text views, then the underlying commonality between them is text view. So why not use text view? So why not recycle text views rather than view types? So it was pretty good. So yeah, these are two alternatives which can work for really complex recycler views. And yeah, so that's about it. So that's all the stuff that I know about Perfetto. And Perfetto itself needs a separate session on itself because there are too many features of Perfetto which are hidden, which are hard to discover. And hopefully, I can give another talk on Perfetto as well as I discover a lot.